This lesson is to help you learn about inverse functions, especially those involving radicals. Let's start out by using our algebra skills to find the inverse. So f of x is our function, and to find the inverse, what we're going to do is we're going to rewrite the original function and we're going to switch the x and the y. So I'm going to write it as x equals the square root of y minus 2 plus 2. Add 2 to both sides. Now to get rid of the square root, I need to square both sides. Now this is a binomial, so I'm going to have to use FOIL. And when I do that, I get x squared minus 4x plus 4, and that equals y minus 2. The square root goes away since the square root and squaring are inverse functions. Add 2 to both sides and I end up with x squared minus 4x plus 6 equals y. Remember, the notation for inverse looks like this, with the f with the -1 that kind of looks like a power, but it's really not. It's really a fancy math notation to designate the inverse of a function. Let's see what those look like graphically. Remember, we switched the x and y. We found out that the inverse of this function was x squared minus 4x plus 6. For my original function, I made a little table. If I put 2 in, I get 0 plus 2, which is 2. If I put 6 in that function, I get 6 minus 2 under the square root, which is 4. The square root of 4 is 2. 2 plus 2 is 4. And if I put 11 in, 11 minus 2 is 9. The square root of 9 is 3, so that equals 5. Now, I can just switch my x and y values for my inverse. At 2, it should equal 2. Let's see if that works. If I put 2 in for this x, I get 2 squared is 4 minus 4 times 2 is 8 plus 6. And that does equal 2. If I put 4 in, I get 16 minus 16 plus 6 equals 6. And that's what I should get, because remember, I'm reversing my x and y values. If I put 5 into my inverse, I get 25 minus 20 plus 6, which is 5 plus 6, which is 11. And notice these are also reversed. If I graph these points, I have 2, 2, so I'm looking at the blue graph now, 4, 6, and 5, 11. So this is what the inverse looks like. And I can do that if I have one set of x and y, then I can just switch those and get the values for my inverse function. How do you tell if something is a function? You may remember in an earlier unit we talked about the vertical line test. If I can draw vertical lines through the graph and it only intersects each vertical line only intersects one time, then I know that it is a function. Now, the graph of this one is a function, but this is what the inverse of that function would look like. If I use the same vertical line test, notice that it fails. So the inverse is not a function. So mathematicians came up with another way to test this, and it's called the horizontal line test. This time I'm going to draw a horizontal line through my original function. Notice that this function fails the horizontal line test because it intersects it in two places. And this is sort of a quick check. Without having to graph the inverse, you can just do the horizontal line test on the original function. If the original function fails the horizontal line test, then you know that the function is, then you know the inverse is not a function. Another thing that you need to know about inverses and compositions of functions is that if you have f of g of x and you have g of f of x and they both equal x, then you know that they are inverses of each other. So let's look at an example. That sounds like a whole lot of complicated math, but it's really pretty straightforward. So if f of x equals this and g of x is this, so I want to show that these are inverses. I want you to try this on your own paper, but I'm going to help you get started. For f of g of x, this means that I'm putting the g function into the x of my f function. So I'm going to rewrite it like this. And then for my g function, I'm putting my f function in it, so it's going to look like this. Putting all of that in, the 4x squared plus 1, and then don't forget the minus 1/4. Okay, so stop the video and work those out, simplifying them, and see if they equal x. Here's that example worked out. Notice that they both end up equaling x. So what that means is f of x and g of x are inverses.